Alright, I'm going to do some inverse functions and show how you would do this. This kind of relates to the parent function. It also relates to 1.9 and the work that we're going to be doing on it. But also, mainly the focus today is going to be like the problems that you have as parent functions. How do you find the inverse of those? What do you do? So I'm going to start with a few here. I'm going to do one. This first one is going to be a square root function. So f of x is equal to the negative square root of x minus 2 minus 3. Okay? And first thing I'm going to do with an inverse function is change that f of x back to a y, because the thing with inverse functions, step one, is switch x and y. So I'm going to switch x and y, and now I have x equals negative square root of y minus 2 minus 3. This is now the inverse. And that is the thing that I'd like to say real quick about the parent function, is if you have a t-chart where you've plotted x and y, and you have whatever numbers for your x and whatever for your y, all you have to do to graph your inverse is switch your x and y to where now you have the whatever numbers and 1, 2, 3, 4, 5, and that is your new x's and y's. And so that switch from just change x and y is how you can get 5 points to graph for your inverse function. Now then, to actually figure out what that function is, we have to do a little bit of algebra. So I want to get this y by itself, and to be able to do that I need to get the square root by itself. So first thing I'm going to do is add 3, and so now I have x plus 3 is equal to a negative square root of y minus 2. And then I'd like to get rid of this negative here, so I'm going to divide by a negative 1 or multiply by a negative 1. Doesn't really matter how you think about it, but now I have a negative x minus 3 is equal to the square root of y minus 2. And now that I have the square root all by itself, to get rid of that, I'm going to square it, because that is the opposite of square rooting. And now I have negative x minus 3 squared is equal to y minus 2, because when you square the square root, they cancel each other out. Last thing, to get y by itself, I would add 2. And now I have my inverse function, which would be y equals negative x minus 3 squared plus 2. And that is the inverse function of the square root function that we started with back up here. Okay? That's a good, it's got all the parts to it, every component to it. And if you were doing a cube root, you would just, this step right here, you would cube it. If you were doing a squared function or a quadratic function, you would just take the square root there. If you were doing a cubic function or a quartic function, you would just take the cube root or the fourth root there. Really, that's the step right here where things would change depending on what type of a function you have. Now let's look at a few that are a little bit different, have a few things that would change there. Let's look at a reciprocal function. So let's say that I've got f of x is equal to 1 over x plus 2 minus 3. So I switch x and y, and now I have, first let's get a y. So y equals 1 over x plus 2 minus 3. And then switch x and y, so x equals 1 over y plus 2 minus 3. And now I need to get the y by itself, so add 3, and I have x plus 3 is equal to 1 over y plus 2. Now then, I'd really like that y plus 2 to be on the top. So I would like to do the reciprocal of this side, right, to switch these. If I do that, then I also need to do the reciprocal of this side over here. So that's going to flip it to where I now have 1 over x plus 3 is equal to y plus 2 over 1, but I don't really need that over 1 there. And then last thing, just minus 2 from both sides, and I have 1 over x plus 3 minus 2 is equal to y. And there is my inverse function for my original function that I started out with. Not a big change on the reciprocal functions there, but a little bit different. Now let's do an exponential function. So let's say that your function was f of x equals a 2 to the x minus 3 minus 2. Well, same thing, get a y. After that, what am I going to do? That's right, switch x and y, and then solve for the new y. So add 2, so now I have x plus 2 is equal to 2 to the y minus 3. Well, now, how do I get the y out of the exponent and get rid of this base 2? Well, the opposite of exponents, of an exponential function, is a logarithmic function. So I'm going to switch from an exponent to a log. So this base here of 2 is going to become my base on the other side, and I'm going to have log base 2 of x plus 2 is equal to y minus 3. And now I have add 3 and add 3, and I have log base 2 of x plus 2 plus 3 is equal to y. And there is my inverse function for my original function up here that I started with. Good? So that is exponentials, that's reciprocals, that's square roots, that's basically everything except for absolute value. So let's look at an absolute value function. Let's say f of x is equal to the absolute value of x minus 4 plus 1. So same basic process, y equals absolute value of x minus 4 plus 1, and then switch x and y. And so now I have this, right? And I want to get y by itself, so minus 1, x minus 1 is equal to absolute value of y minus 4. Now, how in the world am I going to get rid of absolute value bars? Well, if I think about a basic absolute value, let's say x is equal to the let's say 6 is equal to the absolute value of x. Well, what could x be? X could be 6, or x could be a negative 6. So really, it can either be equal to what's on this side of the equal sign, or it could be equal to the opposite of that. So y minus 4 might just be equal to x minus 1. Or y minus 4 might be equal to the opposite of x minus 1. Which means that a negative x plus 1 might be equal to y minus 4. So then add 4 to both sides, and negative x plus 5 is equal to y, or add 4 to both sides here, x plus 3 is equal to y. So I either have this one or I have this one. Well, how do I know which one to use? Well, it depends on what the x value is. Sorry. There, through the magic, we now have this thing graphed with an XY chart, the original, right? This is f of x right here. And I want you to notice what happens if I switch all the x and y's. So if I switch all the x and y's and take my inverse, right, of f of x, then over here I now have x's 3, 2, 1, 2, 3. And my y's are now 2, 3, 4, 5, 6. Well, our problem is this thing is not a function. This right here wouldn't match up because I have 2 points that are kicking out different y values, or the same point that's kicking out 2 different y values. So when I graph that, I'm going to end up with a function that looks much different, but one that looks like, if I were to plot those really quickly, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 4, and then from there it's opening like that. All right. Now then, this is a problem because this doesn't pass the vertical line test, so it is not a function. So how do I write it if it's not a function? And that's the problem that we run into. So we have to kind of write it in terms of a piecewise function in terms of y. So then I'm going to write a piecewise function right here to be able to describe the inverse of f. So this function right here is what I'm trying to write an equation for. So x plus 3 would be this part right here. And that part only exists if y is greater than, or let's do greater than or equal to, 4, right? Then, then the other part of this exists if y is less than 4. And so then I have a piecewise function, a really weird piecewise function, because this does not really make sense with the x's and the y's the way we have it, to where you have the top part and the bottom part. But that's as close as you could come to writing a inverse function in terms of x for what we have there, which is not a function. You could also just put kind of an if statement here for right now, if y is greater than or equal to 4, and here if y is less than 4. And that would probably be enough for the parent function project as we work on it right now. This is by far the hardest one to get an inverse of because the inverse is not a function. Alright, good luck. Come and see me if you need more help.